In the last video, we talked about how to find critical points, and that would be by taking the derivative and setting it equal to 0. What I'm going to show you now is how to expand upon that and do what we call a sign chart, and it will help us determine a lot of other things as well. So for example, what we're going to do is we're going to start by taking this derivative, which we already have here, and this is the one that was in the last video. If we set that equal to 0, remember that we determined that the critical point was at x equals 0. Now what we do is we make a sign chart. So we just make a line, and we're going to call it f prime of x. You always want to label your sign chart because we are going to do some other sign charts besides just f prime of x eventually. So what you do is any of your critical points, now we only have one and it's at x equals 0, so we're going to put that on our sign chart. So now we know that that is our only critical point on our derivative. Now, to make a sign chart, what we simply do is we're going to pick a number that would be less than 0, and we're going to pick a number that's going to be greater than 0. And since we're doing a derivative sign chart, we're going to put it into the derivative. So let's say we pick -1. So we're going to do, basically what we're going to do here is we're going to just do 2 times -1, which is -2. So since this number here is a negative, so let's look at another example. So let's say I had the function f of x equals x cubed plus 3x squared minus 9x. So you can see underneath I took the derivative. Now remember what we do is we're going to take that derivative and we're just going to simply set it equal to 0. Now this is an example where I'm not really exactly sure what x cubed plus 3x squared minus 9x looks like. Okay, so this is where taking the derivative, doing a sign chart may be a little more helpful to us. So what I'm going to start by doing is I'm just going to do basic factoring, and I'm going to take out a 3, and I'm going to get x squared plus 2x minus 3, and set that equal to 0. Okay, so then I'm going to get 3, and then from there I should get x plus 3, and then x minus 1, and set that equal to 0. And then you should see that we have x equals -3, and we have x equals 1 as our two factors. All right, so now what we're going to be doing then is we're just going to be doing a sign chart. Remember that we always label it. So in this case, it's the sign chart for the derivative, so I'm going to write f prime. And we're going to put the 2 zeros that we got, okay, our 2 critical points. Remember, critical points, one of the ways we can get critical points is where the derivative is equal to 0. So there's our 2 critical points. Now what I'm going to do is I am going to plug in points. Now because I'm doing a derivative sign chart, I'm going to be plugging in numbers into the derivative. Okay? So if I plug in something like -4 and I square it, multiply it by 3, plus 6 times -4 minus 9, you will work all of that out and you will end up getting a positive number. Next, you're going to pick something between -3 and 1, like 0. Okay, and 0 makes life a lot easier if you pick 0, and you should end up with a negative number. Then I'm going to pick something like 2. I'm going to plug it again into the derivative, and again, take my word for it, we will end up with something that is positive. Okay, now by looking at this, what we see is, if we look here, we see that f of x is increasing in 2 spots. Okay, it's increasing when x is less than -3. It's also increasing when x is greater than 1. All right. Next thing we also notice, or you should notice, is that f of x will be decreasing when x is between -3 and +1. Okay, because the derivative is negative. If the derivative is negative, the function is decreasing. If the derivative is positive, then the function is increasing. All right? Now, the next thing I want to talk about, though, just a little bit, is let's look at that sign chart again, because I want to show you a shortcut that I like to use to find the signs. Now, as I said, let's look at the derivative. So the derivative was 3x squared plus 6x minus 9, and we set that equal to 0, and we factored, and we found the negative 3 and the positive 1. Now, certainly, as I said, you can plug in numbers and see whether you get positive or negative and whatnot. Now, I do know that this graph is a parabola, and it's a parabola pointing up. And basically, it's a parabola pointing up, and my zeros are at negative 3 and at 1. So it's going to look like, if I can get my pen to work, there we go. It's going to look like that. Do you notice, and again, this is the derivative though, okay, this is not the function. So do you notice that before negative 3, it's above the x-axis, thus this plus sign. Then between negative 3 and positive 1, notice that it's below the x-axis, thus the minus sign. And then again, after 1, do you notice that it's above the x-axis, thus the plus sign. So any parabola that we have that has a positive value of a, your signs will be plus, minus, plus on your sign chart, okay? Between your critical points, plus, minus, plus. Now, another thing that we also should take note of is when we have a sign change, and I'm going to just rewrite this here. If I have a sign change about negative 3 from a positive to a negative, that makes this negative 3, it makes it a max for the function, what we call a relative maximum. So the function will have a maximum at x equals negative 3. Now, likewise, if I have, from the derivative, this is, remember, a sign change from negative to positive, and we do in this case at x equals 1, then what we do is we call that a minimum. Excuse me. So whenever we have a sign change in the derivative from positive to negative, I will get a max for the function. And when I have a sign change from a negative to a positive in the derivative, that means the function will have a minimum at that point.